All right, today we are starting with notes again. We're going to be at 4.4, writing and graphing inequalities. There are some symbols that I want to show you, which you'll see at the very top of your notes. The very first symbol you'll see there is less than. You can see underneath it, you could also use words like fewer than when describing this symbol. So if I was to have something that looks like this, class, read to me what this right here says. X is less than 5, okay? So this symbol right here that I want you to remember, that means less than, okay? Let's go on to the next one. If it said something like this, read me what that says. X is greater than 10. Very good. You could see also you could use words like more than, all right? Now let's look at the next one. This one looks slightly different than this one over here did. Can someone explain to me why it looks different? What is different about that symbol versus the first one? What do you think, Maddie?
Less than and or equal to.
You are correct. If you look at this little tiny line right there, it's basically symbolizing the equal sign, okay? So that sign right there means less than or equal to. Now, there's a few different phrases that it could mean. If you saw the words at most, you would use this symbol. If you saw the words no more than, you would use this symbol. So I want you to imagine that I had something that looked like this. Some reason that you might use something like that is if you were to say something like, if you want to eat off of the children's menu, you cannot be any greater than or no more than 10 years old. Okay, so what number could fit in right here for the X? What is something that is no more than 10 years old? Noah? 2 years old. Okay, so a 2-year-old could eat off that menu. What's another number that could go in there? 6. Okay, a 6-year-old could eat off that menu. Now, what about an 11-year-old who came in? Could they eat off that menu? No, because here's what it says. You cannot be any more than 10 years old. So that would be a time when we would use that symbol. Let's look at this very last symbol right here. If this said X is greater than, let's just imagine it said 54 inches, okay? So that symbol means greater than or equal to. It could also mean the words at least, or it could be no less than. Imagine that you went to Islands of Adventure and it said you cannot be less than 54 inches. How many of you have ever been sad because you couldn't get on a roller coaster you wanted to, that you just weren't quite tall enough, okay? No less than 54 inches. If I was 55 inches, could I go on the ride? Yes. If I was 53 inches, could I? No, because 53 is not greater than 54 inches, okay? So we're going to go ahead and use these symbols to help us with our lesson today. For this one right here, we've got real world inequalities, so some things that could actually happen. If somebody was to say, we have at least 3 students from our school in a chess tournament, the first thing you're going to do, because we're going to try to write an inequality here, you're always going to start with an X. So let me have everyone go ahead and put an X. Next up, what number did you see there in problem A?
3.
A 3. Now, this is the trickiest part, coming up with which inequality symbol we want. Remember, an inequality symbol is less than, greater than, less than or equal to, or greater than or equal to. So here's the clue words. It says at least 3 students. Let me have real quick Olivia stand. Let me have Noah stand. Let me have Anaya stand. Okay, so if I say at least 3 students from our school are in the chess tournament, could I have these 3 students in there, yes or no?
Yes.
I could. That is at least 3. So could it equal 3?
Yes.
Yes, it can. So I could put my equal sign. Now it says at least 3 students. Let me have Olivia sit down. Would this be okay with only 2 people standing, yes or no?
No.
No, that's not at least 3. Let me have Olivia stand back up. Let me have Riley stand up. Am I allowed to have 4?
Yes.
Yes, because I still have at least. All right, let me have Zaria stand. Am I allowed to have 5 people, class?
Yes.
Yes, all it says is at least. So which symbol do you think I can have here? Greater than or less than? It should be greater than, because I need at least, and it should be right there. You could say X is greater than or equal to 3, because that is at least. Problem B says your ring size is less than 7.5. Every time we're going to start with our variable, let's use the variable X. The second thing I will always write down is the number. What number is in problem B?
7.5.
7.5. Now let's just read it. Your ring size is less than 7.5. So guess what symbol I have to put?
Less than.
Less than. This one was actually pretty simple. Next up, the temperature is no more than -1 degree Fahrenheit. Does anybody want to try to do this one for me? Noah, try it out. What's the first thing I want to do?
Right, -1.
Okay, the first thing I'm going to do is put my X. And then we do know our number over there is -1 degrees Fahrenheit. And now you got to see it says it's no more than -1 degrees. Okay? He says to put the equals for sure because if it's not more than -1, it can still equal -1. All right? So now let's think. If it's no more than -1, Noah, can it be greater than -1? This is what it says. It cannot be more than. So he says, no, it can't be greater than. Then, if it can't be greater than, what does it have to be? Less than. So everybody read to me what it is, the inequality he just came up with. Go ahead. X is less than or equal to -1 degrees Fahrenheit. Read it one more time to get yourself familiar with how to read it. Read it from left to right. Go ahead. X is less than or equal to -1 degrees Fahrenheit. Excellent job. For this one, we're going to write the word sentence as an inequality. Problem A says a number x plus 5 is less than or equal to -7. This is pretty self-explanatory. Who thinks they can help me with what to do on this one? Kalani, what should I do? Okay, a number x, so we're just going to put an x. She says add together plus 5. Then what? Less than or equal to -7. That one was pretty simple, right? It almost was like they did it for us. Just reading from left to right, that is how you would write that as an inequality. Next one, problem B. A number x is at least -10. So reading from left to right. Kaylee, what should I do? I'm going to put an x. Oops.
And then you do -10.
Okay, she knows the -10. Now this is the trickiest part right here. Where you see it says at least. Since this isn't something that tells us specifically, it's greater than, it's less than. You got to start thinking through. So Kaylee, if it says it's at least -10, could it be more than -10? It says at the very least it will be -10. Okay, very good. If it says it's at least, that means yes, it can be more than, all right? Then the next thing you see, if it says it's at least -10, is it allowed to be -10? Mm-hmm. Yes, it is. So what else do I need to put here? The equal sign, because it is allowed to equal exactly -10. C says twice a number y is more than -5/2. Does anyone think you might understand what that means where it says twice a number y? What do you think, Maddie? Times 2, okay? So not just one y, twice y means 2 times y. Then as you keep reading, it says it's more than, so we're going to write our more than symbol, and then just the last part, -5/2. And that is how you write word sentences as an inequality. Okay, so a couple thoughts to share here. A solution of the inequality makes the inequality true. What is a solution? Not a problem. The answer, okay? So the solution or the answer of an inequality is what makes the inequality true. Then it says there are infinite solutions to inequalities. So that means there's a lot of different answers. Like earlier when we had said, you can eat off the kids' meal if you are less than 10. There's an infinite number. There's a lot of different numbers. 2-year-old could eat off of it. A 5-year-old could eat off of it. A 6-year-old could eat off of it, okay? There's not just one answer whenever we're talking about inequalities. Now remember, inequalities are when we have those symbols like greater than, less than, greater than or equal to, and less than or equal to. So let's look here. Number 2, we're trying to figure out whether or not the given value we've talked about here is a solution to the inequality. So the inequality it gives to us first here says y minus 5 is greater than or equal to negative 6. Now here's what it's asked us. It says y equals negative 2. So what I'm going to do right now is I'm going to go ahead and plug in a negative 2 to where that y is at. So if I erase this, instead of having y minus 5, it's going to be negative 2 minus 5 is greater than or equal to negative 6. Okay, once again, all you've done right here is you are simply taking this and plugging it in to there. All right, all I'm doing is just plugging it in. So now let's work on the left side. As you can see here, it says negative 2 minus 5. What is negative 2 minus 5?
Negative 7.
Negative 7. And then I'm just going to drop this other part down. Negative 7 is greater than or equal to negative 6. Now, I just want to remind you about a number line, okay? Because a lot of times when we're dealing with negative numbers, people get tricked up. Let's imagine negative 7, 6, negative 5, negative 4. You remember as we get closer to 0, these numbers right here are getting bigger. So which one is the tiniest here? A negative 7 or a 0? A negative 7 is the tiniest number. So let's look now at this problem. Negative 7, is this true? No. Negative 7 is greater than or equal to negative 6. Is that true? No, it is not true. Okay, people sometimes get confused, but no, that is not true. So the question asked, is that a given value of the solution? Is that true? The answer is no. We're going to try another problem that looks exactly like that. Before we do, though, can someone remind me, when I have a number right next to a letter, what does that mean?
Multiply.
Multiply, okay? So what I'm going to do now, it says negative 5.5y is less than 14. We're going to go ahead and plug this in to that y right there. So instead, what is it going to say? Times negative 2, and then we're just going to bring this down here, is less than 14. Now, remember, you guys are allowed to use calculators for this section, but sometimes our calculators have struggles with negative numbers. So let's remember what we know about this. If I am multiplying a negative times a negative, my answer has to be positive, okay? Because two negative numbers will always equal a positive. Now, you can put this in your calculator, 5.5 times 2, or just think, what is 5.5 doubled? What would it be, class? 11, okay? So this right here is 11, and now I'm going to drop everything else down. Is this a true statement? 11 is less than 14. Yes. Yes, so guess what? The answer to your problem is yes. That is a given value, that is a solution to the inequality. Okay, so something that we want to know, right here we're going to write an inequality that's represented by the graph. This right here, what do those two symbols say, class? Greater than and less than. That, whenever you see greater than or less than, it's going to be symbolizing there with an open circle. Now let's come over here. What do those symbols say? Greater than or equal to, less than or equal to. Anytime you have that equal to sign, it's going to be used by a closed-in circle, or a circle that's been all shaded in. So let's go ahead and talk through this. First things first, I want you to look at this first graph right here. Whenever you're trying to write an inequality, you're going to start with your x. So let's write the x. The next thing you're going to do is you're going to look to see what number the circle is on. Class, what number is the circle on?
-3.
-3. So we're going to put a -3 here. Now what you've got to do is try to figure out which symbol we're going to put in here. For this symbol right here, we have an arrow. As you can see, the arrow is going that way over to the right. So do you see what symbol this looks like? What does it look like? It looks like, if you see right here, I'll make it big, that looks like a greater than symbol. So guess what? Greater than is going to go in there. Okay, now here's how we can figure this out, okay? Let's start with this number right here, a 1. As you can see, this whole thing has been shaded over this way. So I'm going to just see if this 1 can get plugged in here. Would this be a true statement? 1 is greater than -3.
Yes.
Yes, so that helps you to understand that the arrow needs to be going to the right, looking like the greater than symbol. Let's go to problem B. The first thing you're going to start with is your variable, so let's put an X. The second thing, I need a number. What number is going to go here, class? -2. Now we've got to figure out which inequality symbol we're going to use. So now we need to figure out, is this greater than or equal to, or is it less than or equal to? Who thinks they might know which symbol should go in there? What do you think, Riley?
Less than.
Less than symbol is correct, okay? Notice, once again, I'll make it really big. This symbol looks like that. This symbol is going that way with your arrow, okay? The arrows should be facing in the same direction. Now, should this be equal to? Let's go back up here. The only time that something should be equal to, do you see that? Do you see this one? This one has the equal to symbol, which means it's a closed circle, all right? Is this right here a closed circle or an open circle?
Open.
It's an open circle, so that means it does not equal a -2. The only things it would equal are anything that is less than a -2. I want you to try to do problem C on your own. All right, who would like to help me with problem C? Zaria, what should I do first?
Write down X.
Okay, I'm going to put my X. What should I do second?
Put 2.
Put a 2. And now what symbol do you think I should do?
Greater than.
All right, she says greater than. And that's it?
Box it in.
All right, and box it in. Would you guys agree or disagree?
Disagree.
Okay, someone help me out if you disagree with her. What do you think, Riley?
It says for a closed circle, it has to be equal to.
Okay, so she pointed out here, do you see that kind of a circle right there? It says it's a closed-in circle. That means that 2 is a solution that we could use. So we need to make sure that we also put what, Zaria?
The line under it?
The line under it, which means it can equal it. Now, here, once again, there's a few ways to double check. This is saying anything going in this direction could be true. So on our map, yes, or on our graph, it says 2, 3, and 4, but also it could keep going, 5 and 6 and 7. It could go all the way up to the number, let's say 100, okay? So could I plug in a 100 right there and that would be true? 100 is greater than or equal to 2, yes or no?
Yes.
Yes, that is true, okay? What about over here? We didn't shade over this section, but could I plug in a 0 right here and have this be true? 0 is greater than or equal to 2?
No.
No, okay? So you know that you have done it in the correct way going that way and that it is being done correctly, okay? So the answer is X is greater than or equal to 2. Okay, for number 4, we're graphing the inequality on a number line. So the first thing you want to do is go ahead and draw yourself a line. A number line can have tons of different numbers, but in our class, we only need to put 3 numbers. Normally, what we think of is we have to put a 0 in the middle, but I'm going to teach you different. When we are graphing inequalities, whatever this number is right here, that is going to be the number that we put in the middle of our graph. Now, on a number line, you always have one smaller number to the left and one bigger number to the right. What is 1 smaller than the number 2?
1.
1. What is 1 bigger than the number 2?
3.
All right, so if we had kept going on, we would have 4, 5, 6, but once again, we're only going to do 3 numbers on our number line. The first thing you want to decide is this an open circle or a closed circle? Notice this says X is less than 2. What do you think, guys, open or closed?
Open.
That is an open circle. Why?
Because it's not equal to.
Because it's not equal to. That means 2 cannot be a solution to this problem. So that's why it's an open circle, so we don't think that the 2 can be. Now what we got to see is a 1. Could I plug in a 1 right here and say 1 is less than 2, and would that be true, yes or no?
Yes.
Yes, it would. So we want to shade over and go in that direction. Okay, now let's just check this out. If I were to take a 3 and plug it in right there, would this be true? 3 is less than 2. No. So we know that we should not be going in this direction because it should be everything that is smaller and going to the left. I want you guys to try to do the graph on problem B on your own. First things first, what did you write? In the middle.
-2.
What's 1 smaller than negative 2? No. Negative 3 is smaller. Negative 1 is bigger. Okay, think about it. If we kept going and you had multiple, then it would go 0, 1, 2. So be careful. It always seems backwards in our mind when we're doing negative numbers. But remember, negative 3, then negative 2, then negative 1. Okay? And also remember, you only need to put just 3 numbers. Okay, is this a closed circle or an open circle? Closed. Please make sure I can tell that you have shaded it in. Now let's go ahead and see what we should plug in. Think about it. Think about negative numbers like dollars. Would this be truthful if I plugged this in and I said negative 3 is greater than negative 2? Is that true? No, it is not. Okay, I would rather have negative $2. So I know I do not want to go this way. All right, instead, let's see if I can plug this in. Could I say negative $1 is greater than negative 2? Yes, I could say that. So then I know that my arrow needs to be going that way. For the final problem today, it's modeling real life. It says a rock climber's sleeping bag is recommended for temperatures no less than 15 degrees Celsius. Write and graph an inequality that represents this scenario. So I want you just to take your pencil and go ahead and underline this area right here. No less than negative 15 degrees Celsius. This is what we need to write for our inequality. So we're going to always start with our x, and then we're going to put our number. Now the hardest part is figuring out which inequality symbol we want to put there. If the question asks us, it says it is no less than negative 15 degrees. If it cannot be less than, then it has to be what? It has to be greater than, okay? So anytime that something says no less than, that means not less than. All right, so we know it has to be greater than. Then my question is, if it says it's not less than negative 15 degrees, can it be exactly negative 15 degrees? Yes, it can. So what do I need to put in there? The equals sign. Now it has asked us to go ahead and graph it. How many numbers do we put on our graph? 3. Just put 3 numbers in. Which number goes in the middle? Negative 15. Now remember, we're talking negative numbers here. What is 1 smaller than negative 15? Negative 16. What is 1 larger than negative 15? Okay, just the boys. Is this an open circle or a closed circle? Why is it closed? It says equal to. That means negative 15, this right here, that could be an answer, okay? Negative 15 is a solution to it. Now I've got to figure out what should I shade in. Is this one correct, negative 16, or is negative 14 correct? Which one could I plug in up here, class?
14.
I could plug in the negative 14, which means I need to shade over the negative 14. Now remember, if you were to keep going on and on and on and on way over here, I would eventually get to a big number like, let's say, 50, okay? Could I plug in this right here? 50 is greater than or equal to negative 15 degrees, yes or no? Yeah, I could plug that in, okay? So just remember, there are infinite amount of solutions. It just keeps going on and on forever. So this is how you would write and graph an inequality. All right, so tonight's homework is over 4.4. These 9 problems are going to have to do with all the lesson that I taught you from today.